good morning, good afternoon, I should say. Thanks for being with us, and welcome to Coherent's 2026 OFC Technology Innovation Briefing. I want to thank all of you here in the room with us, as well as all of you listening online. We greatly appreciate the interest. Before we begin, I've got to refer you to the customary forward-looking disclosure statements on slide 2 in the presentation deck. It will be posted to our website, the Investor Relations section of our website, later today. The full presentation, all of the disclosures today are covered by those disclosures. Any forward-looking statements are covered by the disclosures. They apply to any and all forward-looking statements that may be made. Now for the agenda. CEO Jim Anderson will provide an overview of our data center communications segment. Jim will be followed by Julie Eng, our CTO. Julie's going to discuss scale out and scale up. Julie will be followed by Dr. Beck Mason, EVP of Semiconductor Devices. He'll discuss lasers in indium phosphide capacity. And he'll be followed by Dr. Sanjay Parthasarathi, our Chief Marketing Officer. He'll discuss scale across. That'll take about 60 minutes. We're going to follow that up with a Q&A session. That'll be about 30 minutes long. Finally, Jim's going to provide some closing remarks. And last but not least, I'd welcome any feedback from any of you following the event. Regardless, if I could be of any help at any point in the future, feedback or otherwise, it would be my pleasure. Without further ado, I want to welcome Jim to the stage.
All right. Thank you, everybody. Thanks for being with us here today. Really appreciate you being here, especially here in person. I know there's a lot of things going on at OFC, a lot of demands on your time. So thanks for spending time with me and the rest of the team. And then also thanks for everybody that's joining us online as well. So we're here in Los Angeles at OFC. I was walking the floor this morning, and this has got to be a record OFC in terms of size and number of people. I mean, each OFC just keeps getting bigger and bigger, and I think it's really a testament to how important photonics, optics continues to become across so many different applications. So Coherent always has a big presence at OFC. We've got a lot of products and technology that we're demonstrating here at OFC, and happy to give you an overview of that today. By the way, the beginning of OFC, the first keynote kickoff this morning was by our own CTO, our illustrious CTO, Julie Eng, and she was nice enough to carve, she's famous now, so she's nice enough to carve a little bit of time out for us for our event here. So anyway, thanks again for being with us here today. So I think there's probably never been a better time to be in the photonics industry than right now. The photonics industry, optics, the innovation that we're bringing is touching so many different applications across so many different markets, data center, communications, industrial applications. So today we're going to focus on data center, but it's incredible to see the reach that photonics is having across so many different industries. So in data center, which again, that's the focus of today's discussion, if you look at data center today, across the scale out and scale across networks, already 100% optical, 100% optical networking, and growing at an incredibly rapid rate as we continue to add compute capacity across the network. But what we're really excited about is kind of the next frontier of bringing optics to scale up part of the network and to help drive future data center innovation with photonics. Now, the reason that we're now starting to see photonics migrate into the scale-up network is the same reason that photonics took over scale-out and scale-across. And the reason is that you take any length of distance in the data center, whether it's 3 meters or 3 kilometers, and if you crank up the data rate and if you crank up the total amount of bandwidth, eventually you hit a point where photonics is the most power efficient, fastest way to transmit that data across that length of distance. And so now what we're starting to see is to continue to drive data center architecture, now adoption of photonics and scale up. And so that's great for the photonics optics industry. That's a massive TAM expansion for the industry, but really good for Coherent as well. So when we look at Coherent, again, I don't think Coherent has ever been in a stronger, better position than we are today. And we're going to talk about today the opportunity in front of us. Kind of think about it in two parts. So part one, we'll talk about all of the existing engines of growth that are driving our growth today. And if you look out through the coming years, that's about a $50 billion market opportunity, probably a little bit more than that. And that covers, just for a few examples, that covers pluggable transceivers. So we'll talk about our ramp of 1.6T. We'll also talk about the roadmap to 3.2, 6.4, and beyond. We'll talk about DCI transceivers, transport and transmission, and then all the different optical components that go into those products. So certainly talk about our existing growth engines. But what I'm really excited to talk about today, and what you'll hear from the team as well, is the new growth engines. What's driving, we believe, an inflection in our growth rate moving forward, an acceleration of that growth moving forward. And there's four in particular that we want to talk to you about today. If you look in aggregate across these four new growth engines, collectively those add over $20 billion of incremental market opportunity over the coming years. And these are not things that are way out in time. These are things that are starting to ramp over the next few coming quarters. And that's why we're really excited about that. So number one, we'll certainly talk about optical circuit switch, OCS, really excited about that. The market is much larger than we thought a year ago at OFC. The number of usage models, the number of usage cases has grown considerably, and we are on a very fast ramp of ramping our manufacturing capacity to meet the demand that we're seeing in front of us. And that's already ramping today. So that's ramping each quarter throughout this year and into next year. The second big growth area for us is CPO and NPO. And I've asked Julie to spend a good amount of her time talking about CPO and NPO today for both scale up and scale up, or both scale up and scale out. That is a huge incremental TAM for the optical industry and especially for Coherent. And this is near term. We'll start to see first revenue from CPO in the second half of this calendar year. And that the ramp will start in scale out, but towards the end of 2027, we expect to start to see the ramp of scale up as well. The next area we want to talk to you about is multi-rail. This is a new product category. We've got tremendous excitement from customers in this product category. And again, this is near-term revenue. This will start to ramp in the first half of 27. And then the fourth thing that we want to talk to you about today in terms of new growth engines is thermal solutions. Now, this is something we haven't talked a lot about to date, but given that it's starting to ramp next year, we want to start to talk to you more about this. This is us using proprietary materials technology that Coherent has developed for industrial applications and repurposing that for data center applications. And not just thermal cooling, but also harvesting heat from the data center and recycling that into electricity. And so we'll talk about that as well. So we're really excited about the new growth areas. We think that as these come on and they layer on top of each other, that provides us with an inflection and acceleration of our growth rate over the coming quarters. And in aggregate, if you look at all these in aggregate, these are all a tailwind to our gross margin and our business model. So that's what we'll talk about over the course of today. I do want to take a few minutes here at the beginning to talk about the partnership with NVIDIA that we announced a couple weeks ago. We've had a long history with NVIDIA. Over 20 years, NVIDIA has been a customer of ours, but this is a step function expansion in that partnership, and we're really excited about it. I was at GTC yesterday at Jensen's keynote where he talked about CPO in both scale out and scale up. And so great to hear them already talking about that. This partnership is entirely incremental to what we're doing with NVIDIA today, and it's all around CPO for both scale out and scale up. The supply portion of this agreement, the development and supply portion is a multi-billion-dollar, multiple product opportunity, and it spans out through the end of this decade. And the different products that go into this partnership with NVIDIA, not just the laser, but the other products as well, we'll talk about through the course of today. And we're happy to answer any questions about this partnership when we get to the Q&A as well, but really exciting for us. So you hear from me all the time. You hear from me at least once a quarter, probably more often than that. So since today is more geared around products and technology, I want you to hear from the experts in the products and technology. And so we got 3 sections that we'll go through. Number 1, our CTO, Julie, will talk us through scale out and scale up, both the existing growth engines as well as the new growth engines. So she'll talk about pluggable transceivers and the roadmap there. I've asked her to spend an extra amount of time on CPO and NPO, given the huge growth there. And she'll talk about OCS and thermal. And then the second section will be led by Beck Mason. Beck leads our semiconductor products group, and I've asked him to do a bit of a deep dive into our laser portfolio and our indium phosphide capacity. This is a area that we get a lot of questions from investors, a lot of interest in this area. So he'll talk about all of the different laser technology that we have, the EML, the CW, and the VCSEL lasers, how those are used in both pluggables as well as CPO, NPO. But I've also asked him to spend some time on our indium phosphide capacity because we're ramping that very fast. We're doubling that this year, and he's going to share with you our expectations of capacity expansion next year as well. And then finally, Sanjay will wrap up with scale across. So I'll talk about DCI transceivers, transport transmission, but also that new multi-rail technology system that starts to ramp early next calendar year. So if anybody needs a photonics doctor today, we've got you covered. We've got 3 doctors of photonics in the house today. So before I hand it off to the 3 doctors, I just want to reiterate, thanks for being with us here today. We're at an inflection point in an acceleration of our growth. It's really that combination of the expanded use of photonics in the data center, the broad range of technology that we're bringing to our customers. You'll definitely see that today. And then the manufacturing expertise and the scale of manufacturing as well. So with that, I'll hand it off to Dr. Number 1, our CTO, Julie Eng.
Thanks, Jim.
Sure.
Hi, good afternoon, everybody. Nice to see a lot of familiar faces, but for those of you, if I haven't met, so I'm Julie Eng, I'm CTO of the company. I've been with the company over 20 years. I've been in optics my entire career, and I want to echo what Jim said is it's a very exciting time to be in optics. I mean, if you think about it, the AI data center is basically a massively distributed supercomputer. And when you do parallel processing, the performance of the system depends a lot more on interconnects. And we are the interconnect. So optics is now becoming a key architectural element in the architecture of the AI data center. And I think things like our partnership with NVIDIA show how that our customers see that as well. And also, I feel very happy and confident, not just about the market. So the market and the opportunity are great, but I feel very confident about our roadmap and our depth and breadth of technology. So yeah, let's talk about the data center. Starting first, defining our terms, the domains inside of the data center. So the scale up domain is the networking together of multiple XPUs or processors, accelerators to act like a single compute node. And the scale out domain is the networking together of those nodes to form that distributed supercomputer that is the AI data center. So talking first about the scale up or scale out, that's a heterogeneous environment. And what I mean by that is you might have equipment from different people that have to plug and play. The distances can be very different, 10 meters to the rollover or 10 kilometers up through the ceiling and across a Costco-sized warehouse data center. Flexibility is very important in this portion of the network. And this portion of the network is optical today, and it's all served by pluggable transceivers. The scale up is very different. This is a closed system, and what I mean by this is it's owned by the person who networks inside the rack or a small cluster of racks, and they don't have to operate with anything else, interoperate. It's copper today. The distances are less than 10 meters. And because it's in the rack, Density, cost, and power consumption are very important. And as we see this domain transition toward optical, it's a great fit for co-packaged optics. And of course, for us, since it's 100% copper today, this is a SAM expansion. So in the flexible portion of the network, where flexibility is prioritized to scale out, you see pluggable transceivers because they offer flexibility. There's a robust roadmap that we as an industry agree on of increasing bandwidth density, and I'll talk a little more about that. There's a standardized multi-vendor ecosystem which gives security of supply. They're easily serviceable because they plug in through the front faceplate of the switch. And they defer the architectural commitment. And what I mean by that is once you deploy the switch on the floor, because the optics plug into the switch, the data center operators can decide after the fact whether they want that switch to go 30 meters and use VCSEL-based transceivers, or 500 meters and use silicon photonics-based transceivers, or 10 kilometers and use indium phosphide-based transceivers. And they can make that decision literally after the rack is on the floor, and they can change their mind after the fact if they want to. So that's a lot of flexibility that's very valued by our customers. But on the other hand, co-packaged optics for us is a SAM expansion. And so what is co-packaged optics? So co-packaged optics is really just like an LPO transceiver that's made smaller, and it sits right around the switch or XPU like that picture on the bottom there. And so why would you do that? The main reason you do that is because you don't have to drive the electrical traces to the front of the box, and that reduces power consumption. And then since you're not pushing all the optics through the front of the box, that helps you increase faceplate density. So but you give up something for that. Now everything is inside the box, and you lost that great flexibility that I just talked about. And so it's a trade-off where you need bandwidth, higher bandwidth density, and power and better power consumption compared to if it's more important to you than flexibility, then you would do that. And so that's a really good fit for that scale up portion of the network. So let's just talk about what is CPO really. And really, CPO, I call it an architectural repartitioning of the optical transceiver. So there's a picture of one of our transceivers up there. And what you can see is that all the elements, first you see that column under pluggable transceivers with the green checks. So that green check is everything you need, the significant optical components that you need inside the pluggable transceiver. Now those green check marks also happen to be our capability. And what that means is every critical optical component that's in a pluggable transceiver, we design and manufacture. Now, the CPO I'm showing at the bottom, that's actually a rack unit that would plug into a rack, and where those white little pluggable things are, that's the front of the rack. And so we're looking at it from the top down, and what you see is there's the switch or XPU, and then like say the modulators, detectors, laser drivers, transimpedance amplifiers go in those little orange boxes all around the switch or XPU. And then in some architectures, you plug the laser in through the front. You might be familiar with the ELS term, and those are those white elements there. When you look at what's in CPO, you look all the way over to the right, and all those checkboxes are what's in CPO, and all those checkboxes are actually things we have internally. And I'll show you a little bit more about that. So we have a strong roadmap for pluggable transceivers. We're continuing to ramp 800G. We have a broad portfolio of 1.6T. We have a full suite of transceivers, including all of the types of lasers, as well as TRO, FRO, and LRO. And here at the show floor, if you haven't been there yet, we're showing 3 different versions of 1.6T around 3 different DSP vendors. And I'll talk to you a little bit more about 3.2 and 6.4 on the next slide. So in order to increase bandwidth density of pluggable transceivers, we do 2 things. The first is we increase the data rate of every line, and the second is we try to fit more lanes inside the box. So on the left-hand side, you'll see what we are doing for the industry to go up to the next speed node to drive the bandwidth density of pluggable transceivers. And we're showing on the show floor a 400G full-length demo with an indium phosphide EML. That's our own EML designed and manufactured in-house. And we're also showing it with our own 400G photodiode, also designed and manufactured in-house. On the bottom, what you see is a 400Gi with silicon photonics. So this would have our own CW laser, our designed silicon photonics fabbed in a silicon fab. And that's actually the first time that anyone's shown a 400Gi with silicon photonics. So we got what's called a post-deadline paper, which sounds like we just missed the deadline, but it's actually the late breaking news of the conference. And so that'll show on Thursday afternoon. So that's like a very proud moment to have a post-deadline paper, and that 400G silicon photonics is one. And on the right-hand side is what we do to increase density. So you might have heard of this new form factor. It's called XPO. So today our OSFPs are 8 lanes of 100 gig or 200 gig. The XPO actually jumps to 64 lanes and partly does that by integrating water cooling into the module. This was announced by Arista and ourselves and a bunch of other partners supporting this form factor. And the reason you would use, it's literally just the next generation of pluggable form factor. And the reason you would do this is it enables what was shown at the conference is it enables essentially collapsing something that used to take 4 rack units. You can now collapse down to 1 rack unit. So it's just higher bandwidth density. But the insides of the transceiver are roughly the same as they were before. And these can support, because it's got 64 lanes of 200 gig, it can support up to 12.8 terabits per second. And then we're also driving an innovation at the OIF, which is a standards body, called the high density form factor, which does the same thing but ups the data rate to 400G, which is 25.6 terabits per second. So what you can see is there's a long, robust roadmap of pluggable transceivers, and we're a leader in that area. And we're also showing the XPO live in our booth as well. And so I often get the question, well, first, actually, I'm sure your eyes are going to go to the SAM. So let me talk about the SAM. We are upping our SAM for CPO. Our new SAM for CPO, our estimate is $15 billion by 2030. And I often get the question, what can you make for co-packaged optics? And so I've tried to make it really explicit here. So I'm showing you that same rack unit that would plug into a big rack. This is the top-down view, and in the front are those ELS, external laser sources. So we could sell a silicon photonics PIC. We design silicon photonics PICs. We use them in our transceiver. You can use them in CPO. We package the silicon photonics PIC and or VCSEL, actually, you could package into something called that little CPO or NPO module, or sometimes people call it an optical engine. That would be all the orange things around. And so that's something we sell into CPO and NPO. The external laser source, which I'm sure you've all heard of, that has our CW laser in it, which Beck will talk about. We also, I think make, design, and manufacture a significant fraction of the world's isolator. So the isolator protects the laser from back reflection, which would otherwise hamper its performance. And we also design and manufacture thermoelectric coolers, which keep the laser at a constant temperature. So either we could sell at any of those levels, the external laser source, CW laser, an isolator, thermoelectric cooler. And then on the other side, you need to get the light from that external laser source to the silicon photonics PIC. And that takes a lot of passive optics. And that's something maybe we haven't talked about quite as much externally. They're usually inside of our transceivers. But in this case, what you see is you can use this small passive. It's a very precisely manufactured and designed passive, actually, called a prism micro lens array. It takes the light from the fiber and shoots it down into the silicon photonics. And it also requires something called polarization maintaining fiber, which we also design and manufacture internally. And when you put those together in a fiber, something called a fiber attach unit, and we design and manufacture those internally as well. So you can see the broad array of products that we can make for CPO. And so I want to show you what we're showing at OFC. This is what we're showing at OFC this year related to CPO and NPO. And one comment I should make is NPO just means it's not on the package. So it's still inside the box, very close to the switcher XPU, and that's what NPO is. What we're showing, I think we have we definitely have the broadest and deepest portfolio of CPO technologies. And I'll show you how here. So on the floor, we're showing a 6.4 terabit per second silicon photonics-based socketed CPO. So another moving forward on CPO is looking at sockets. And the advantage of a socket is that it makes it more easily serviceable. It means you could have different types of CPO that would all fit in the same, location. There's a downside. It takes space and there's some maybe signal integrity trade-offs there. But there's a lot of interest in socketed CPO. And so we, together with others, founded a socketed CPO MSA. It's called OpenCPX. We just announced it last week. And so this is a silicon photonics-based socketed CPO demo. It's 6.4 terabits per second. And it fits about on the size of the top of my thumb. So if you think about that for a second, you've probably seen an OSFP, and it's the equivalent of 4 OSFPs, but now I'm putting it on my thumb with the exception of the external laser source. So super proud of that, very excited about that. With that, we are showing also the demo is with our own fiber attach unit, which has our own micro lens ray and our own polarization maintaining fiber. And we're showing that with our ELS, which has our indium phosphide CW laser, our isolator, and our tech. So it's end-to-end coherent solution. Then we're also showing VCSEL-based CPO and NPO. And the VCSEL actually is an interesting potential for silicon photonics because the power is very, very low. The energy efficiency is good. So when you look at a VCSEL-based solution, it has a path to what we call 1 picojoule per bit, and maybe that doesn't mean that much to you. It's basically between 4 and 5 times lower power than the silicon photonics solution. But it doesn't go as far. It's shorter reach, but there's a lot of short reach distances inside the data center. And in the VCSEL-based solution, you usually have the laser in it. And so there's some pluses and minuses of that. But I do think that these will coexist in CPO, NPO, just as they have in pluggable transceivers. And so I'm showing there in the picture our 2D datacom array of VCSELs. So VCSELs are usually made in a one-dimensional array, but now Beck's team is making them in a two-dimensional array. And then next to that is a little NPO, near packaged optics, that's VCSEL-based that you can also see on the show floor. And you can see how small it is next to that penny. And then finally, we're showing, I believe we're the first to ever show, CPO based on indium phosphide. And so this is 4 lanes of 400G indium phosphide Mach sender modulators integrated with semiconductor optical amplifiers. And that's important because semiconductor optical amplifiers are very helpful in closing the 400G link budget. And down there you see our 400Gi. And so again, I think the depth and breadth of our CPO and NPO is unmatched actually in the industry. So I'm very proud of that. And I think that for reasons like this is why you see such a strong partnership with NVIDIA and people who are working, to be the leaders in CPO and NPO deployment. Okay, changing gears now, staying inside the data center, but talking about optical circuit switch. So we are also increasing our SAM for the optical circuit switch from $2 billion to $4 billion. Jim alluded to, we feel like maybe we undercalled it last year at this time. And I'll tell you why I think we undercalled it is that the use cases are actually broader than what, let's call it, I can speak for myself, than what I thought last year. And the customer base is broader. And I think the customer adoption is faster than we thought. So let me try to walk through those pieces. So what really is the use case for optical circuit switch? When you think about it, I think the primary use case, there might be like a lot of sub-uses of it, but the primary use case is our customers can send a software command and then connect how all the fibers are connected inside anything that's touching the OCS, how all those fibers are reconnected. And so one example that might matter to our customers is suppose they're doing like a huge training model 1 month, right? And they want all the fibers connected in a certain way because they're going to use almost all their GPUs for that one training model. And then 2 months later, let's say, they want to do a whole bunch of small training models. They might want the fibers connected all differently. And so what they can do is send a software command and the fibers get connected differently. And that's very important because XPUs are so expensive too. So being able to almost on a job level optimize the topology for the workflow for the maximum utilization of those expensive GPUs is very, very valuable. And I think as our customers started to realize this and think of all the different ways they can use it, that's how we're seeing the use cases expand. And one example, some of our customers have talked about having a hot swap rack. And if something happens in one rack, they literally use the OCS to fail over to the other rack to keep their uptime and not lose where they are in their training. And we are actually seeing customer interest in scale up, scale out, the spine, and scale across. So all different kind of locations and use cases. And as Jim mentioned on our last earnings call, we've shipped to over 10 customers, and we are shipping into production deployments. And there on the left, you see the 320 by 320 OCS system. And just as a reminder, we do all of that software ourselves in-house, and we have a very skilled software design team that our customers are often complimenting us on how good our software is actually. Okay, and then just a reminder that our technology, we believe, is differentiated. We're using the liquid crystal technology. So MEMS is kind of like a moving mirror. It can either move up and down or tilt to move the beams around. And anything that moves, usually you don't want something that moves inside the data center if you can help it. In addition, the liquid crystal, it takes less than 10 volts so in the liquid crystal, we're just turning molecules. So that's a lot easier. And then to turn those molecules is only 10 volts, whereas a MEMS system can sometimes be 100 volts, 200 volts. And also our customers have spoken publicly about how high voltage components fail more often than low voltage components. So we believe we have differentiated reliability, which I think our customers would agree with us on. And we're seeing strong sequential growth. We're ramping capacity to meet our growing demand. As Jim has mentioned on the earnings call, we're shipping 64 by 64 and 320 by 320 into multiple customers. And we have a 512 by 512 in development, and I think you will be able to see that on the show floor. And finally, just wanted to end up with our thermal management. So these thermal materials, they're in our industrial segment. But because in this case we're using them toward the data center, we decided to present this to you today. And this is the first time we're putting a SAM on this. And we're putting $2 billion by 2030. And let me tell you what it is. So these are very specialized thermal materials that today we sell into semi-cap equipment, for example, and other applications. And they're finding a new home in the data center. And why is that? The reason that is these accelerators, XPUs, GPUs, they run at like a kilowatt. And getting the heat out of them is very important to their reliability and their performance. And so a couple of the materials that we have are very valuable for that. So we have thermodite, which is our patented, our own name, and it's our own proprietary material. It's actually a diamond silicon carbide ceramic. So since it's a ceramic, you can like fire it, you can machine it. We literally use our own industrial lasers to machine it. So, and that helps with the heat away, efficiency of heat transfer, double that of copper. In addition, we're seeing interest in silicon carbide substrates because that can get the heat away about twice as fast as silicon, actually. And then finally, as Jim mentioned, we have some ways in which thermoelectric coolers that we use to keep a constant temperature in the laser can actually be used in reverse to take the waste temperature delta of your waste heat and turn it into energy, actually, which for energy reclamation in the data center. So these very, very interesting thermal materials, we have a lot of customer engagement because it's just very valuable to our customers to be able to improve the reliability and the performance of the XPUs. So with that, that's the data center for today. Thanks for your time, and I hope you see the excitement that I feel and the breadth and depth of our strong roadmap. And let me hand it off to my colleague Beck, who will talk to you about lasers and indium phosphide capacity.
Thank you, Julie. So good afternoon. My name is Beck Mason, and I lead the Semiconductor Device Business Group at Coherent. I'll give you a little overview today on some of our laser technology, the breadth of our technology in semiconductor photonics, and also talk about what we're doing to scale up indium phosphide capacity. I've been in this semiconductor photonics business for a little over 27 years. I started my career as a device researcher at Bell Labs. And I can honestly say that there is no more exciting time in this field than right now. The pace of volume growth is unprecedented, and the pace of technology evolution is faster than it's ever been before. So it's both exciting and challenging for us. So Coherent is a very broad and deep technology leader in semiconductor photonics. We have arguably one of the broadest portfolios of devices of any company in the world. We make very high-speed indium phosphide-based EML and DML lasers, and we have solutions that go up to 400 gigabits per second. And we've been shown to be a leader with the first company in the world to demonstrate differential EML technology. I'll talk a little bit about that later, but it's important because it enhances overall link integrity for data center transceivers. We also have very high volume indium phosphide CW lasers. These are the devices that are used to power silicon photonic transceivers today that we sell across our data center customers. And we have even higher power versions of those that we're developing and engaging with customers on, which deliver 400 milliwatts per laser. And these are the critical components that are enabling the external laser sources for CPO growth. Finally, we're also a VCSEL manufacturer, and we're one of the leading VCSEL manufacturers in the world. We have extensive gallium arsenide wafer fab capability, and we've developed VCSEL solutions that scale from hundreds of gigabits per second to 200 gigabits per second, and then in aggregate capacities in array-based solutions into the terabits per second. And I'll show a little bit more on that technology today as well. To date, we've shipped over 1 billion VCSEL devices to the field in communications, and over 500 million indium phosphide devices. And if we count the non-com semiconductors we make, it's well over 3 billion units. So indium phosphide, I think most people have heard how important indium phosphide is to scaling of data centers, and specifically AI data centers. So currently we are running 4 separate indium phosphide wafer fabs. Our first fab in Fremont, California, is where we've developed our high-power CW laser and high-speed photodetector technology. That's a 3-inch fab, and it's a fab where we've got more than 20 years of experience delivering devices into the data center market. Our next fab in Sherman, Texas, is the first fab where we've deployed 6-inch indium phosphide production. It is the most advanced indium phosphide fab in the world. It's a very large facility with capability to scale to meet the huge growth and demand we're seeing. It's the first place where 6-inch indium phosphide has been put into production, and we are making multiple different product platforms in that fab. It's also a very high volume gallium arsenide fab for us where we make our 3D sensing products. The next fab is in Järfälla, Sweden, which is just north of Stockholm. This is also a fab we've had for more than 20 years. It's the home of our advanced EML technology. It's also where we make our most complicated photonic integrated circuits that are used in the scale-across applications. And it's the second fab where we've installed our 6-inch production capability and are ramping our capacity significantly. And then finally, because of the unprecedented growth we've seen, we are adding a 4th fab to our indium phosphide group, and that's our wafer fab in Zurich, Switzerland. This is also a fab with a very long history. It's a very high volume 6-inch gallium arsenide fab today, and we're adding a substantial amount of 6-inch indium phosphide capacity into that location as well to scale it up. Overall, as I said, we're seeing unprecedented demand for indium phosphide devices, and we're seeing it across the full range of our products from many of our customers. And we're in the process of locking up long-term strategic agreements with these customers to guarantee that they will have the capacity they need as they scale, and for us to guarantee that we will have secure supply to deliver to. So we are focused really in Coherent on having the most advanced technology possible in our fabs. And we've done that by going to the largest wafer size. Going to 6-inch indium phosphide doesn't only help us with scale, it lets us deploy the most advanced semiconductor process equipment in the world into those lines. That gives us higher yield, better throughput, lower labor costs, a whole bunch of benefits. In fact, we're currently running 3 main categories of devices on 6-inch indium phosphide: EMLs, high-power CW lasers, and high-speed photodetectors. And all 3 of those categories, we're seeing higher yield and better throughput efficiency on our 6-inch lines than we've been able to achieve even on our very mature 3-inch production lines. As I said, we're ramping capacity in Texas and in Sweden, and now adding that capacity in Switzerland. And we fully expect that we will double our total capacity by the end of this year, and we're planning to double again or more by the end of next year. And we're going to keep increasing after that. So the scale of growth for us is very rapid and very fast, and we wouldn't be able to do it if we didn't have such an advanced platform to work on. So I'm going to switch gears now a little bit and talk about innovation, because innovation is a core platform of what we're doing. So we are today a technology leader in EML technologies, and EMLs are really important devices for data center transceivers. And if you want to know what an EML is, it's a very, very tiny laser that we fabricate a very, very fast modulator in front of. And that modulator is used to turn on and off that light and encode data at up to 400 billion bits of information a second. And then we aggregate multiple of these together in transceivers, and we can deliver aggregate data rates up to 6.4 terabits per second or beyond. So we have been in high volume production on 100 and 200 gig EMLs for some time. We have last year demonstrated our 400 gig EML technology. We're demonstrating even more capability there today. And we continue to ramp and grow those platforms. We were also the first to introduce a new type of EML called a differential EML. And the reason this is important is it provides much better signal integrity and much better modulation efficiency. And that matters because as you go up in data rate per wavelength or per device, you need to get more and more link budget to meet the requirements in the data center. And to do that, on those higher capacity links, everybody wants to move to these differential EML technologies. So being a leader in that space has really driven a huge interest and a huge growth in the demand for our semiconductor devices in transceiver modules. And another place where that's really important, Julie talked about OCS. So OCS deployment is growing in data centers. And the one downside of OCS is it does introduce additional link loss. And so it requires higher link margin in transceivers. And that's another place that's driving the use of differential EML technology. So in addition to very fast EMLs, we make very high power CW lasers. And today we do these in very high volume to support silicon photonic based transceivers. And the really exciting point of this is the same technology platforms we use to develop the 100 milliwatt lasers that we use in our silicon photonic transceivers are now being used for our 400 milliwatt lasers for CPO applications. And CPO is growing very, very rapidly. Again, we're in full production on our high power CW lasers, both on our 3-inch platforms and our 6-inch platform in Sherman, Texas. And we've got some very unique and differentiated IP in this space that's very defensible. So we have, using more advanced semiconductor processing tools, we've been able to develop a laser with very, very high yield across the wafer, very low phase noise, which gives you better link integrity, and very high power conversion efficiency, even at those higher output powers that are required. And that's driving our customer engagement. So we have extremely strong customer engagements across multiple customers for this technology. And we've already secured very large multi-year orders that are going to guarantee our demand for several years to come in this space. So it's definitely a place where we've got tremendous customer pull and engagement. So finally, I want to switch to the third class of devices for data center, and these are our VCSELs. So we've been long a world leader in VCSEL technology. To date, we currently deliver 400 million VCSEL devices a year for data center and sensing applications. And our arrays for sensing applications actually contain hundreds of VCSELs per chip. So we know how to make very large arrays as well. Our VCSEL technology now, we're one of the first in the world to get to 200 gigabit per second capability. So that's the highest data rates people are currently deploying. And we have unique technology that allows us to make single mode VCSELs, which help us to extend the reach of those in fiber networks much beyond what's traditionally been able to be achieved. The beauty of VCSELs is they lend themselves enormously well to large arrays. First of all, VCSELs are very low power and very efficient ways to transmit data, but they're also very convenient for making large arrays. And we make today 2-dimensional VCSEL arrays, both with conventional top-side emitting and new backside emitting VCSEL designs. Backside emitting are very convenient because they enable you to flip chip the device for easier integration. But also we can integrate micro lenses on the back of those chips, and those integrated micro lenses greatly enhance their ability to package and integrate those solutions at very low cost. And our VCSEL technology is in high demand today. We obviously are in very high volume production of VCSELs across data center transceiver applications, and we have a number of engagements with hyperscale customers working on VCSELs for CPO applications because of their very compact size and really good power efficiency in those applications. So lastly, all of these great technologies to transmit light over the fiber wouldn't be much good if we didn't have something on the other end to receive it. And so we have a broad array of internally developed photodetector technologies, from 50 gig to 100 gig to 200 gig to 400 gig per lane capability in both indium phosphide and gallium arsenide. We make large arrays of photodiodes for more efficient packaging in data center transceivers. So if you've got a multi-lane transceiver, you can use our quad array photodiodes in that application. And we make our photodiodes, again, in flip chip configurations with integrated backside lenses. And those integrated backside lenses, again, are to facilitate coupling of light into the detectors with very high efficiency, very robust, high tolerance for that coupling efficiency, and that drives low cost. The key to this is Coherent has a full end-to-end capability of semiconductor photonics, from the transmit to the receive side, from the highest performance EML technology through CW technology for silicon photonics, down through VCSEL and shortwave. And that deep technology stack gives us a huge advantage in time to market, in innovation when we integrate those into our CPO and transceiver products, in better cost and better supply chain resiliency. And I think that's a huge differentiator for us in the market. Thank you very much for your time. I'm now going to pass it off to my colleague Sanjay, who will speak about our scale-across technology.
Thanks, Paul. Wow, it's great to be here, and it's so nice to see so many familiar faces in the audience here. Sorry. Here. Okay. So for those of you who don't know me, I've been with the company for over 2 decades. And prior to my appointment as the first CMO of the company in 2019, for 15 years, I ran what is now our communications business. I ran product marketing and product management, or our scale across business. So you can imagine, I'm especially thrilled to talk about our innovation and scale across. Data centers are power constrained. So this means that large AI workloads now have to be distributed amongst multiple data centers. And that drives a need for high bandwidth, low latency connections between the data centers, or the scale across network. And in parallel, over the last, I would say, 4 or 5 years, the optical networks are becoming increasingly disaggregated. So from large monolithic systems, they're giving way to smaller, easy to deploy functional elements. And 2 such critical enablers of scale across are data center interconnect transceivers and transport equipment. Now, data center interconnect transceivers, or DCI transceivers, they sit at the edge of a data center. They convert electrical signals to optical signals, and then get them ready for transport. And transport is, as the name implies, are systems that take the signal and transport them, carry them from one data center to another. And the distances from these data centers, between the data centers, can be anywhere from tens of kilometers to thousands of kilometers. So let me first start with our DCI transceiver. We have a deep vertical technology stack. Every photonic component in a DCI transceiver we make. And this ranges from indium phosphide tunable lasers, the same indium phosphide platform that Beck talked about, to modulators, to silicon photonics-based planar integrated circuits, indium phosphide-based planar integrated circuits, detectors, passive optics, thermoelectric coolers. We even make a few ICs. And we also take these components and package them into tiny subassemblies, such as the nano ITLA, which is an integrated tunable laser assembly. And we also take the tunable laser and combine it with the receive optics, and we make a product known as an IC TROSA. So I'm super excited to announce that our new high-power, narrow line width tunable laser is now ramping in production for both in-feed into our own DCI transceivers, as well as packaged into a nano ITLA for the merchant market. And I'm also thrilled to also announce that our IC TROSA, an extended C-band IC TROSA, won an award yesterday at this very OFC. By extending beyond the C-band, that enables our data center customers and hyperscale customers to drive more efficiencies from their fiber infrastructure. We have an industry-leading roadmap on DCI. Let me start with 100G ZR. In the 100 ZR, we took all the complexity and all the smarts of coherent transmission and detection and compacted it into a tiny pluggable QSFP28 form factor. The reception from the customers has been fantastic. Today, we have over 40 revenue-generating customers for this product. And we continue to innovate in the platform. So in this OFC, we announced the ramp-up of a BiDi product. Okay, what is BiDi? It's bidirectional transmission. So it is a transceiver that allows you to transmit and receive on the same fiber. So that doubles the efficiency of the fiber infrastructure. And we also won an award yesterday for a low latency version of the same product. And you can imagine how important latency is for DCI scale across networks. Moving on to 800G, we were the first to introduce a 800G pluggable transceiver into the market for coherent transmission. And we quickly followed it with an L-band version. Again, going to the L-band enables our data center customers to double the efficiency of the fiber plant. And we've got 1.16 development. We are also working on 3.2T. Okay, now moving to the transport equipment. Transport equipment serve many important functions, including multiplexing, demultiplexing, essentially taking multiple wavelengths of light and putting them on the same fiber, amplifying the signals, switching routing, and then monitoring the health of the optical signal, as well as monitoring the health of the underlying fiber infrastructure. For the past 20 years, improving efficiency has been the biggest mantra in transport equipment. And we are a pioneer and an innovation leader in transport. We have a long list of unique and industry-first innovations that we have brought to the market, starting with the merchant EDFA in the late 90s. There's too many on this list, but let me spend a couple of minutes on a couple of these products. The dual chip pump completely changed amplification. By combining the functionality of two pumps in a single pump, you get significant power, cost, and space savings. And it essentially a step function change in amplifier performance. With the embedded OTDR, we created a market. We created an entire new market segment for monitoring the health of the underlying fiber infrastructure. And my personal favorite is pluggable optical line systems, which we affectionately call poles, where we took an entire line system and collapsed it into a pluggable form factor. And multi-rail is our latest in this long history of transport innovations. So what are multi-rail systems? Transport equipment are usually housed in enclosures like the one that you see in this photograph. We call them fiber huts or amplifier huts. This one looks like it's in a residential neighborhood. There is snow around. and you can see the power going into the hut. And some of these are temperature controlled. So there is additional power that you need for temperature stabilization of the devices there. And now with the demand and scale across, our data center customers and hyperscalers are demanding multi-fold increase in transmission capacity. Now that creates a major challenge for this fiber hut. For example, if you want to go 4 times more capacity through the existing infrastructure, today, the state of the art, current systems, you need 4 times more equipment, 4 times more power, 4 times more space, and of course, 4 times more cost. And this is where our multi-rail comes in. It's truly groundbreaking innovation. What multi-rail does is it allows you to process 4 times the traffic within the same space and with a sublinear scaling of power. It's truly a groundbreaking innovation. Now, how do we do it? Okay, now I'll come back to what I said earlier. 4 times, 4 rails in one tiny 1 RU or 1 rack mount unit. So how do we do it? You've got to open up the hood of the multi-rail, and you'll find many award-winning innovations there, starting with the rate amplification. And the rate amplifier basically does the function of multiple amplifiers in the same space, and again, with sublinear scaling of power. And how do we make an array amplifier? With the dual chip pump. In this particular case, it is a quad chip pump. So we have 4 chips in one package, uncooled, 700 milliwatt per pump. So really, really innovative product there. Then we also have a multi-port dynamic gain equalizer. What is a dynamic gain equalizer? Well, when you transmit multiple wavelengths or DWDM signals on a fiber, and you amplify them. When the signals get to the other side, some signals are amplified, some wavelengths are amplified more, and others not so much. That's just the physics of erbium doped fiber amplification. And you need a DGE to level those wavelengths, otherwise you're going to have issues on the detection side, on the reception side. So that is the DGE, and we have compacted multiple lanes of DGE into a tiny package. And then to monitor the signal and do fiber metrology, we have a multi-port OCM and a multi-port OTDR. The OTDR is an optical time domain reflectometer. It monitors the health of the fiber infrastructure. So lots of award-winning innovations. The platform itself has won multiple awards. And at this OFC yesterday, we picked up 2 more awards for our multi-port, for a multi-rail platform. The multi-port DGE and the multi-port OCM won awards as well. So you can imagine the customer reaction for this product has been pretty fantastic. There's been a frenzy of design and activity with hyperscalers, with NEN customers all across the patch. And as Jim mentioned earlier, we are going to be shipping first revenues in early next year. We have an amazing demo of the multi-rail system at our booth. I'd highly encourage all of you to come and see it. I'll invite all of you to those demos. And there are also demos that Julie and Beck talked about. Really, really cool demos at our booth. So please try and make it there. And I think with that, I want to thank you for your attention, and I'm going to pass it back to Jim.
All right. Thank you, Sanjay. Thank you, Jim. All right. I am also very excited about the multi-rail system. So we're going to open up for questions in just a minute. I'm just going to summarize real quick. So look, we're at an inflection point of accelerated growth ahead of us. We talked about all the different new growth engines that we're bringing online over the coming quarters, but really it's a combination of that continued progression and expansion of photonics across the data center, the tremendous breadth and depth of technology and products that we bring to our customers, and then along with that technology, the expertise and definitely the scale of manufacturing to be able to scale and hit the quantities that they need. So with that, we're going to open up for Q&A, and I think Paul's going to moderate our Q&A.
Thanks, Jim. While the guys are coming up on the stage, obviously this is about wow. Can you all hear me okay? If you could keep your questions focused on the topics at hand of today's session. For those of you sticking around, we do have food and refreshments afterwards. And with that, I will open it up. Simon?
Yeah, there's mics that are coming around.
Thank you. Simon Leopold, Raymond James. So a couple weeks back, you did announce the agreement with purchase agreement and investments from NVIDIA.
Yep.
So you talked a bunch about the things they may be doing, but could you maybe connect the dots in terms of what's related to that commitment from NVIDIA? For example, you've got the investment. Where's that CapEx maybe going? What are you investing in? What are your priorities? What have you committed to delivering to them? What kind of visibility do you get from it? Thanks.
Yeah, thanks for the question. So first of all, on the cash piece of your question, so the $2 billion of investment from NVIDIA, we're going to use a good portion of that cash towards just capacity expansion, right? Just given the tremendous demand and their forecast of demand through the rest of the decade, right? This partnership expands or goes through the rest of the decade. And a good portion of that will be indium phosphide, no surprise, indium phosphide capacity expansion, but also capacity expansion for the other products that we're bringing to them as part of this agreement. So the agreement covers multiple products. A lot of those products that it covers, actually all those products that it covers, Julie's covered in her section today. So if you go back to that slide that talks about all the different things that we can provide in CPO applications, that's kind of a superset of the things that we'll be supporting NVIDIA on. So we're really excited. It's a step function expansion in our partnership, and that supply agreement runs out through the rest of the decade. So great partnership, and we're really excited about it.
Samik, we can get a microphone over.
Hi. Thanks for the session, and thank you for the questions. Maybe, Jim, starting with you, as much as yesterday's sessions were very focused on CPO and when it sort of goes inside the rack and outside the rack, you sort of dodged the question, seems like, in your panel. So any thoughts in terms of, as we sort of go through this transition of copper to optics, when are you expecting broader adoption of scale-up outside the rack, and then when does it sort of start to filter into inside the rack? And then a second one, maybe for more Beck and Jim, you can chime in as well. The indium phosphide capacity ramp and the 6-inch transition, maybe an update in terms of how that's going, and when you're saying doubling of capacity next 12 months and another doubling, how much of that is capacity addition versus the transition from 3-inch to 6-inch?
Okay. On the first part of the discussion on CPO, and Julie, you can jump in if you want. The way to think about it is the CPO covers both scale out and scale up, right, that we talked about today. The first CPO will start to ramp in scale out, right, and we'll start to see the revenue from that towards the second half of this year, basically second half of calendar 26. And then scale out will ramp into 27 and beyond. And then we see scale up starting to ramp in the second half of 27. So about a year later, we'll start to see first revenue from the scale up portion. And yeah, no secret, obviously, NVIDIA is lead customer for us, but we are engaged with multiple other customers in CPO, both scale out and scale up opportunities. And we do expect adoption across to multiple customers again, in both domains, scale out and scale up. And then the second question on indium phosphide, remind me.
6-inch.
Oh, 6-inch. So the way to think about all of that capacity expansion that Beck showed, so, he showed that we're going to double it this year, we're going to double it again. That is almost all 6-inch capacity, right? So by the end of this year, as we double the capacity, and that incremental capacity is almost all 6-inch, we'll basically be at a 50-50 mix of 3-inch and 6-inch capacity. And then the expansion again, the doubling again, all that incremental will almost all be 6-inch again. So 6-inch will just continue to become more and more of our capacity over time. And it's really capacity expansion. We're not so much converting lines as we are expanding 6-inch lines. And then as we get a chance, we'll convert 3-inch to 6-inch as well, right? But that capacity expansion is really mostly 6-inch driven. I don't know, Beck, would you add anything to that?
The only thing I would like to say is the beauty of going to the larger wafer size is it's so much more efficient for us to add capacity. And I give you a simple example. We use a lot of these very specialized tools called epitaxial reactors that we buy from a company called Axtron. And these tools grow the indium phosphide layers on the wafer, right? And when we go from 3-inch to 6-inch, we get 2.5 times the capacity per run in the same kind of reactor configuration. So 6-inch is really efficient as we scale, and that kind of scaling goes across multiple tool sets in the fab. So it's really the only way that we can scale at the rate we're going to scale is by doing 6-inch.
Yeah, and the simple way to think about it, because you're getting more than 4 times as many devices out of a 6-inch versus a 3-inch. Every new 6-inch line we put in place is like us putting 4 3-inch lines, right? So we're scaling at 4 times the rate of if we were doing it on 3-inch lines, right?
Yeah.
Paul, I have the mic. Is that right?
Yeah, I'm sorry. It's hard to see with the lights.
People. I have a question for Julie. Julie, wondering if you could walk through the TAM improvement for the OCS from $2 to $4 billion, and just maybe walk through some of the use cases that are driving that TAM expansion. It seems to me, I could be wrong on this, but it seems like most of the OCS deployment today is fine switch replacements. If you see that as being the primary use case as part of that TAM expansion in the near term, or are there other use cases as part of that? And then the second part of the question is you mentioned software being an important part of OCS deployment. Google's doing a lot of work there, and they have been for a long time. How are you seeing other hyperscalers kind of address the software aspect of it? Is that something that you could add value with, or you're going to leave it to the hyperscalers and other customers? Thanks.
Great. Yeah. So I think the OCS use cases, the original use case, I can say, as we all know, it's Google. They published a paper on it, so I can say it was really kind of spine switch replacement. But as I mentioned, I think as the use of OCS sort of coincided with the buildup of AI infrastructure, people have broadened out their thinking on OCS, which is part of what made us think. Well, we actually see the demand also, so that gave us a good signal to increase the SAM. But when you look at it, it's really, as I tried to say, it's any place. You can almost think of it as a new capability in the data center rather than a flattening or a difference of a layer or a place. It's not a replacement for an electrical switch because we're not switching packets. But think of it as a new capability. And that new capability is at a software notice, I can reconnect how all my GPUs are connected. And so if you think about that, you can use that any place. It's not just in the spine. And so that's why we're seeing people have interest in the scale up, the scale out, the scale across, and the spine, actually, I think, because in the end, it's about operating the data center efficiently to generate as much revenue off of the GPUs that you've put in place, actually. So I think that's part of the expansion. And then to your other question about the software, well, I don't know, did you
software?
add anything?
No, go ahead.
On the software so we have an excellent software team. The only time we talk to customers about software is for them to thank us for our great software team. But we write the software that actually controls the OCS given commands from the customer's software. So our software gets integrated into their software, and then they control obviously their network and everything like that. But definitely it adds value. If your software is good and it's easy to integrate, that adds value over something that isn't actually.
Peter Marshall, Morgan Stanley. I guess, could you just expand on gating items to greater Pixel adoption? Because I think, we've obviously, this is, indium phosphide, it can alleviate some of the bottlenecks that we have. We all came from a session where they were kind of saying that Pixels would be a smaller portion of the market. So just how do you see getting over some of the hurdles that have prevented greater adoption?
Yeah. Do you mean in CPO, NPO, or do you mean in pluggable, or both?
I guess.
In both?
Yeah. I mean, the CPO, I think it makes sense to scale up because of the short distance.
Yeah.
And it's greater in the pluggables.
Yeah, I think definitely in CPO, NPO, there'll be short distances, and I think, Julie covered that really well. And we'll clearly see VCSEL adoption in NPO applications, and we're already engaged with customers there. And then in pluggable, even in the pluggable use cases, there are shorter distance lengths that we see even in pluggable applications. And so we think there will be adoption of VCSEL-based 1.6T transceivers in some subset of the market, right? It won't go across all applications, but there'll be shorter reach applications where we expect those 1.6T VCSEL-based transceivers to be adopted.
Hi there. Jean-Marc from Deutsche Bank. You're expanding indium phosphide capacity, but the raw indium feedstock is roughly 70% sourced from Chinese zinc smelters, which are now subject to export permit requirements with multi-month processing times. I guess my question is, how much visibility do you have on indium supply for the next 12 to 24 months? And are you actively diversifying sourcing away from China, or do you hold strategic inventory as a buffer?
We actually have a very diversified supply chain for indium phosphide substrates. We have, and I think I've shared this in the past, we have over 5 different substrate suppliers today, and we work with those suppliers not just on you mentioned next 12 or 24 months. We don't work on just next 12 to 24 months. We work on the next 3 to 5 years of capacity that we're going to need. So we have, in some cases, very long-term agreements in place, and that includes not just the substrates, but all the key inputs that go into that. So we believe that we have very good visibility into substrate supply, and so that capacity expansion that Beck showed is, we have commitments from our suppliers to supply the necessary indium phosphide substrates to support that.
Next question. Okay.
Thank you. Papa Silla from Citi. I guess this question is more for Julie. You had a very helpful slide showing the SAM with different areas of CPU that you can provide. I guess I was hoping if you can maybe parse through within that 15 billion SAM, what is ELS, what is ultra-high power laser, what is PIC? And tied to that, I know you have the capabilities of doing all of those, but if you can maybe help us understand which areas you are already number one or number two, and which areas are you kind of ranking?
Yeah, we believe, maybe I'll kick it off and Julie can weigh in. So on the second part of your question, we believe we'll be a leading supplier in all of the things that Julie mentioned, right? We have line of sight and very clear demand from customers on each one of the things that Julie talked about. And I also want to stress again that there's no other supplier in the world that brings that entire portfolio of technology. And if you're going to go build a CPO or an MPO, a system based on CPO or MPO, you want to be working with a supplier that brings that whole portfolio of technology, because otherwise you as the customer are having to do the integration, trying to put together the supply chain. If you go to Coherent, it's a one-stop shop of that supply chain. And that's a big advantage for us. And a lot of the very critical components, and this is important as well, are done in the right geography, are done in geographies that the customers want it. And that's obviously, like indium phosphide, high power CW lasers done in Texas, right? So very important that we don't just have the breadth, but we've got the manufacturing in the right place, and we've got duplicated manufacturing in a lot of cases, indium phosphide being another good example. And in terms of the breakdown of the 15 billion, we don't have a breakdown today, but maybe at a later time we will break that down into more granularity. But the external, I would say the external laser source module is a significant part of that 15 billion. But then within that, ELS is all the things you showed, the lasers, a lot of times there's focus on just the lasers, but there's a bunch of other components that go in there, the isolators, the thermoelectric coolers, all the things that Julie showed today. The other big portion of that 15 billion is in the fiber attach unit. So that's all of the fiber that goes from the front faceplate to the switch chip or the XPU, also goes back out to the ELS, right? That whole assembly is very complicated optical assembly, difficult to do. Very few companies can do that well. But Coherent, since we've been doing that for decades, right, as part of transceivers and other optical systems that we manufacture, we know how to do that. And that's a very high value piece of that 15 billion as well. And again, there's kind of key components underneath there that we supply as well, like the PMLA that you talked about. And so, yeah, we feel like we've got a very, very good competitive position on that sort of totality of CPO and MPO technology.
Check.
Thank you for the presentation. This is Yang Hu for Carl and from BNP Paribas. I have two questions about your class. So first, it's glad to see now you have expanded engagement on nano ITLA. Can you just talk about your customer engagement, your breadth of customers with external customers, or you are using it mainly for your own modules?
Yeah, I believe we're using it both internally, but we also have external customers as well. Sanjay, do you want to just talk to the breadth of the external customers?
Yeah, sure. So we have a lot of deep customer engagements, both with NEMs as well as hyperscalers. And so the tunable laser itself, we use it as a chip for our DCI transceivers, but we also package it into a nano ITLA to the merchant market. As you know, there is a merchant market for the nano ITLA.
Yeah, I was sitting in a meeting this morning where the customer was asking us to make more, right? So yeah, it's in high demand.
Nice. That's nice to hear. And then about your multi-rail technology, this there's an important technology there. You show the box here. What's your strategy there? Are you going to supply the entire box or components into those amplified boxes?
Yeah, all of the above. We'll supply both the box as well as the key components into other suppliers. So we'll do both.
Okay, thank you very much.
Yep.
Check. Is that Michael?
Is this working?
Yeah, you're good.
Hi, Jake Silverman, Bloomberg Intelligence. I wanted to ask about your material segment that you called out today. You have capabilities across silicon carbide. Done a press release about 2 weeks ago on liquid cold plates, which you mentioned, I think. I'm curious how close you're engaged with some of your customers across these 2027, second half of 2027, and later timelines. This is you kind of intersecting where you think power density within the racks goes and the new materials that are needed for this. And should we expect to see a lot of additional announcements over the coming quarters that start to layer on top of that in 2027 and into 2028 as well?
Yeah, and you should comment too, but we're pretty excited about it. We're seeing there's engagement across multiple customers. It's a very compelling technology. And remember, there's kind of two categories. Category one is, like using thermodite, our proprietary technology, to pull heat away from the switch chip or the XPU, et cetera. And it's much more effective than a copper cold plate at pulling heat away, which is then obviously you can run your XPU or whatever faster. It's better reliability. But the other technology that's really cool is the thermoelectric cooler kind of running backwards, where it pulls waste heat and creates electricity that's funneled back into the data center. If you think about that's pretty compelling to basically any data center owner, because what's the primary constraint right now in data center? It's power delivery, right? So if I can take heat out and recycle it back into power, and that's just like free energy, right? And so that's very compelling to every data center owner. And even if it were just small percentages of recovery of heat, that's very significant. So I would say the customer engagement on both of those is really, really strong. So anything you add?
Just adding. So you can make the liquid cold plate, as Jim said, heat spreaders, and because those materials we can form, and then also silicon carbide wafers, like as a thermal wafer. And in general, I think we are in a very special position that we have all these unique materials, but we have all the contacts in the data center. So we're not just some materials company who knows nothing about data center knocking on the front door, right? So we're working with the customers, and they have to learn, right? This is a new tool in their toolbox. And so kind of they learn about the material, we go back and forth. And so it takes a little while, I think, to germinate, but kind of a totally different product, but not so different than the OCS. That first people have to get used to it. They have to think about it. Then they figure out how they can utilize it. All of a sudden they start coming up with a whole bunch of, like a cascade of options. So yeah, we were at Semitherm last week. That's a big thermal conference. We had a lot of engagements. We had talk, we had a booth. And so I think you will definitely see increasing announcements from us or demonstrations over time before we get to those points where we call that revenue in the SAM. Yeah.
Jim, if I could go back to my sell-side days and ask a follow-up to that. Hopefully it was clear, but as an economic opportunity, the power challenge and the thermal challenges, were those both prominent?
Oh, yeah, for sure. I mean, for data center operators, those are two of the biggest problems, right? Is the data center is limited by the power delivered into it, right? So you're trying to generate as many tokens that you possibly can out of the total energy that you can deliver into that data center. And so this effectively would help you generate more AI tokens per data center by harvesting that heat and putting that energy back into the data center. So there's an immediate economic impact, right?
Yeah, that's that one. And then the other one is like what we've shown with simulation and actually some measurements is that using the thermal materials, we can reduce the junction temperature of the XPU by between 5 and 10 degrees. And that can either, as Jim said, improve the reliability. But what actually I think our customers are going to do is they're going to run the clock speed faster and they're going to get more output. So the output of those that's their revenue stream actually, right? So people are very powerfully motivated. It's really gone from thermal being like, an After Effect implementation thing to being like front and center in the architecture of the AI data center.
George?
Hi, thanks. George Notter from Wolfe Research. Just expanding on the thermodite discussion, I know it's been percolating inside the company for a lot of years, I think. And I guess I'm just curious what the milestones are to see, traction towards customer engagement, customer revenue, products, making real business out of this? Like, what are the milestones you guys are looking for?
For me, the only milestone I ever care about is revenue. So the revenue milestone is, we think, based on the customer engagements that we have, and there's multiple of them, that we start to generate revenue in the second half of next year. So second half of next calendar year. And to me, that's the key milestone, is when does the revenue turn on? Now, there's normal engineering milestones that we go through ahead of that, normal qualifications and pilots and things like that. But the most important milestone is that revenue milestone.
What's reasonable in terms of opportunity for you guys? Revenue run rates?
So we set the TAM, or SAM, I guess, at $2 billion. We always try to be a little bit conservative on the SAMs that are further out in time. I think it could easily be bigger than that. So if we were some portion of $2 billion, look, I think this could be certainly hundreds of millions dollar product line, and could become $1 billion product line for the company. Yeah. Thanks.
It's hard to see in the back of the room. If I'm missing anybody, please shout out.
Should we do this last question?
Yeah.
Yep.
It is maybe another question. Corey Johnson from District Capital Research. In this materials business, what are the barriers to entry to that? How, the lab-grown diamond thing, for example, that seems to pop up in other places. What are the barriers to entry? And obviously, you've got some sales advantages as well.
Yeah, in the materials business, that's a really good question. In the materials business, the barrier to entry is very high, because it's like having a special recipe, right? And it's very difficult to reverse engineer that recipe. Like if you take thermodite, proprietary material we've developed, years and years ago, it's very difficult to reverse engineer that particular recipe. It's like it's like somebody handing you a cake and saying, hey, without recipe, reverse engineer and figure out how to bake a cake, right? If you've never been given a recipe. That's what it's like. So it's very high barriers to entry. So we feel like this is a very well-protected area for us, and something that we have unique expertise in. I mean, we were founded as a materials company, right? This is really deep heritage here. And really what we're doing is we're taking an existing material from our industrial space and just repurposing it for a new application, right? That's what we're doing. Okay.
Right. With that, I want to thank all of you. I want to thank all of you online. Again, for those of you here in the room, if you're hungry, you want food or drink, and if you want to speak to Jim and the rest of the team, we have some time. Thank you.
All right. Thanks, everybody. Thank you. Thank you.